What is Ohm's law in simple words? Hey guys. In today's video, I will explain what is Ohm's law. Ohm's law states that the voltage, V, across an electrical component is directly proportional to the current, I, flowing through it, with the proportionality constant being the resistance, R, of the component. Imagine you have a garden hose in your backyard. Voltage is like the water pressure supplied to the hose. Current is like the flow rate of the water through the hose. Resistance is anything that would restrict that flow, like using a nozzle. Imagine you want to illuminate a red LED. You would connect it to a power source. In this case, the power source is a 9-volt battery. The red LED has a forward voltage of around 2 volts. The LED will illuminate because the battery's voltage exceeds the LED's forward voltage. However, the excessive current in the circuit generates more heat than the LED can withstand, leading to its burnout, as shown in the diagram. We must restrict the current flow by using a resistor in the circuit to protect the LED from damage. What resistance of a resistor should we use? This is where Ohm's law comes to the rescue. Ohm's law states that resistance is voltage divided by current. In our case, V is the voltage of the 9-volt battery minus the 2-volt LED. I is the current of the red LED, which is 20 mA or 0.02 amp. With these values, R is equal to 350 ohms. I don't have a 350 ohms resistor, so I'm going to use the next highest value, which is 470 ohms. With a 9-volt battery, a 2-volt LED, and a 470 ohm resistor, we have our complete circuit. The current passes through the circuit and illuminates the LED without any problems. Let's verify this circuit using a multimeter. Insert the red jumper wire in the positive end of the breadboard. Insert the black jumper wire in the negative end of the breadboard. Connect the red alligator clip to the other end of the red jumper wire. Connect the black alligator clip to the other end of the black jumper wire. As previously stated, I lack a 350 ohm resistor, so I will opt for the next best option available, which is 470 ohms. Bend the wire ends of the resistor and insert them into the breadboard. Insert the LED into the breadboard. Make sure it's in the same row as the resistor. Connect the red alligator clip to the positive terminal of the battery. Connect the black alligator clip to the negative terminal of the battery. The LED illuminates, indicating that the circuit is functioning correctly. Turn the dial to the V symbol with a squiggly line on top, so we can measure voltage. Let's check the voltage on the LED by touching the probe leads to each end of the wires. The LED has a voltage of around 2 volts. This is good and expected. The resistor has a voltage of around 7 volts. As expected, the voltage across the resistor should equal the battery's voltage minus the LED's voltage. You may be asking, how do we know the resistor limits the current in the circuit? You need to measure the current flowing through the circuit to know for sure. This can be done by measuring the current in series within the circuit. First, we need to break the circuit by moving the LED a few rows down in the breadboard. We will determine the current by measuring the flow of current through the probe leads. Unplug the red probe from the voltage socket to the milliamperes socket. Turn the dial to the milliamperes setting. Touch the red probe lead to the right side of the resistor and the black probe lead to the left side of the LED. The reading shows around 15 volts. This is close to what's expected as shown in the earlier circuit diagram. I hope this video has explained what is Ohm's law. Remember to like, share, and subscribe to this channel. I look forward to seeing you in the next video.